Dear student, now we are going to discuss the modeling of electrical and mechanical systems. So first we are going to discuss the electrical system. So here we can model by the three basic elements: resistor, inductor and capacitor. So the circuit consisting of these three elements are analyzed by using of two laws: Kirchhoff voltage law and Kirchhoff current law. So now see here the resistor, the circuit model of resistor is shown in figure. So how we can write? So you might know that the Ohm's law V is equal to IR. Based on that only, here also we are evaluating the parameter in that resistor V of I is V of T is equal to I of T into R. So simply you can remember V is equal to IR. Similarly for that I, we can replace that value. So we will get I is equal to V by R. And the next thing is inductor. So here the circuit representation using a Faraday's law. So V is equal to L into dI divided by dt. So if you want to know the current for this inductor circuit, you need to integrate the values. So for that you can do 1 by L integral of V into dt. Similarly for capacitor, so V is equal to 1 by C integral of I into dt and I C into dV by dt. So here you will know that the charge on the capacitor and we can denote it as Q. So that Q, how you can write integral of I into dt. So if you are replace this integral of I into dt in the double equation, we will have V is equal to Q of t divided by C. So now the next system is mechanical system. So in that mechanical system, there are two types of mechanical systems are available. The first thing is translational mechanical system. Second thing is rotational mechanical system. So the translational mechanical system move along the straight line. The systems are mainly consist of three basic elements. Those are mass, spring, dashpot, and dam. So if the force is applied to the translational mechanical system, then it is opposed by opposing force due to mass, electricity, and friction of the system. Since the applied force and the opposing forces are in the opposite direction, the algebraic sum of the force acting on the system is zero. So now here there are three basic elements involved in the translational mechanical system: mass, spring and damping. The first thing is mass, the property of body which stores the kinetic energy. The force is applied on the body having mass m, then it is opposed by opposing force due to mass. This opposing force is proportional to the acceleration of the body. So here you can assume that elasticity and the friction are negligible. So that means that force of the body, that means force of the mass, is directly proportional to acceleration of the body. So how you can replace with that constant F is equal to m. So what is the acceleration value? D square x divided by dt square. So here the x is the displacement factor and the next thing is spring. So here the spring is an element which stores the potential energy. If the force is applied on the spring K, then it is opposed by opposing force due to elasticity of spring. So this opposing force is proportional to displacement of the spring. So what is the displacement factor here? Dx divided by dt. So remember acceleration is d square x divided by dt square and displacement is dx divided by dt. So now here also you have to assume mass and friction are negligible. So now that spring of the force, that means the Fk is directly proportional to displacement of the spring. So now see here the displacement value here you have to take x. So now you can write F is equal to kx. And now the next thing is dash part. So the dash part here if you are applying the force applied on the dash part, it will be opposing force due to friction of the dash part. So here the opposing force is proportional to the velocity of the body. So what is the velocity factor? Dx divided by dt. So remember that acceleration is d square x divided by dt square, velocity is dx divided by dt and the displacement is x. So now you can, that based on the constant factor in the dash part, so you can replace that fb is equal to b into dx divided by dt. Similarly, for modeling of rotational mechanical system, the rotational mechanical system move about the fixed axis. The systems are mainly consist of three basic elements: moment of inertia, torsional spring, and dash part. So the torque is applied on the rotational mechanical system, then it is opposed by opposing torques due to moment of inertia, elasticity and friction of the system. So now the moment of inertia, similar of mass, it stores the kinetic energy. But instead of force, here you are call it as torque. So if the torque is applied on the body having moment of inertia J, then it is opposed by the opposing torque due to the moment of inertia. So this opposing torque is proportional to angular acceleration of the body. So in the translational system, we are using the parameter x. Similar of thing, here we are using the parameter is theta. So here the angular acceleration, how you can define d square theta divided by dt square. So now that moment of inertia is directly proportional to angular acceleration of the body. So now based on the constant factor of moment of inertia, you can written as j equal to j into d square theta divided by dt square. So now the next thing is torsional spring. So similar of spring in the translation system. Here the rotational system, the torsional spring is stores the potential energy. So here you can remember that the torsional spring is directionally proportional to the angular displacement of the torsional spring. So instead of displacement, here you can write angular displacement. The angular displacement factor is theta. So how can you write Tk is equal to k theta. Similarly, for dashpot, how you can write the torque is applied on the dashpot B, then it is opposed by the opposing torque due to the rotational friction of the dashpot. So this opposing torque is proportional to the angular velocity of the body. So here how you can write the Tb is equal to beta omega. So now that omega value will be that velocity, angular velocity is V into d theta divided by dt. So always you remember here the two systems are said to be analogs to each other means you need that particular thing should satisfy the two conditions. The first thing is two systems are physically different and the second thing is differential equation modeling of the systems are same. Remember two systems are physically different and the differential equation modeling of these two systems are same. So there are two analogy systems are available. The first thing is force voltage analogy. Second thing is force current analogy. So force voltage analogy. So you have to relate the mesh equation of the electrical system compare with the mathematical equation of translation mechanical system. Similar way, that force current analogy is comparing with the nodal analysis of electrical system. So now see here that the diagram. So what are the equivalent elements for the torque, voltage, moment of inertia, inductance? So please note down this tabular column. The next thing is force current analogy. So there are also some comparative tables are there. For the force, the electrical system is current, mass, capacitance, frictional coefficient, reciprocal of resistance, spring constant, reciprocal of inductance, displacement, magnetic flux, and velocity, voltage. Thank you.